So welcome to part 3 and the final part of the forgotten license key write-up. And in this part we focus on breaking with Python the last part that are missing. And for this one here, let me close either, move the terminal a little bit and get our IDE and get here our nodes, our pseudo code that we have recovered from the program. So what we want to do now is to try to brute force the first block. So we have learned that we need to do some XOR operations, and our assumption was that the underlying algorithm here will end up in a simple XOR operation, which XORs our input key with something which is inside the binary, and then the capital S is here. And for the sake of the format of the CTF flags, we want to verify that the first block here will cover these 4 characters here, and then the last the other. But let's focus here on the last 3 elements from the first block, which is here an E, a C, and a capital V. And I have added here our recovered base 64 byte or byte range from the binary, and do here some base 64 decoding to get the raw byte representation. And then we simply iterate here over all possible bytes, and then we check if the result from the first byte, which we have decoded here, XORed with 0, 1, and so on, matches E. Then we have most probably found the expected input. So with this here, let's try to brute force the first block, and this can be A, 4, and 6. And let's prove that here. So I think this was the input that we've used from part 1 of that small series. So therefore let's replace here with A, 4, and 6 and see what happens. And we see the first thing is that our checksum is still valid for the first block, and that we see here the sec capital V and an A, which is a good indicator or is an indicator that our assumption here is correct. And we see also some things that look a little bit more readable, like sec, and here we assume to have an L, then something, rock, something, and this is, I think, a good indicator that we are totally on the right way to solve the challenge here. So for the next thing, I need to quickly check my notes here, and I need to copy it on the other side here. So we need to brute force the 5th char, so we can kind of comment that out here and see what we have, which is a G. So let's replace here 0 by capital G, and with now kind of a problem. We don't know which this one is here, and if this still matches our checksum, and what is the expected output here, because we at the moment only know to have something like this here, but we don't know what is here in between. So therefore we can do we can try to do a trick here. Since we know the part of the key here, From now, let's quickly copy and paste it here for my notes. So after this operation, we know most of the parts of the expected key, and we know from the first part that the expected checksum for the last block, so let's write here the second block, which is the last, was 282. With that, we can try to permutate the last two characters. I think the permutations are imported. Then we can say we want to have all permutations from 47 to 123. And I will quickly copy in here an ASCII table to show you what this numbers mean. And yeah, I cannot scroll here. So we have started by, I think, 47. I think this time in decimal. To have here the forward slash, yeah, but you can for sure include 43, and it will end up right here to have only uppercase, lowercase, and the numbers and some of the special characters inside the possible solution range, just to decrease the time a little bit. So let me get rid of the ASCII table here, and then let's define here a simple list as a possible solution range, and then say for all p's in our permutations, we want to get the combination, which is P0 and P1. And then let me copy and paste here. And let's have the part here. So let's see for the moment what we have here as an output. I would say the solution range here is way too long. So what we first need to check if our permutation that we have found so far matches the expected checksum. So therefore we can simply add here 3 lines with S, and then reloop over the length of the part, which is the last 4 characters here, and then we can simply say if S is 282 to our solution range, we want to append the part, and right after we can say for block in solution range we want to print the block. So maybe this decreases the possible solution range a little bit here, and what you see also way too much here. The next thing here is that we also want to check if the part is printable, so that we have only printable characters inside. I think we can call it with printable. And let's see here. I think it's also way too much. Yeah, but we can maybe right now script here, yeah, and test every input to the program. But I think we can do that a little bit better. So let's say we have a brute force here, which is the first known part of our first key, and then we want to say let's maybe get let's use this line here. So we want to test. Let me quickly paste here. I need an XOR function. I think I can quickly define it here. Let's define it here on top. So simple XOR. And let me quickly check for my notes what was the test input. It was the formatted block. So let's copy and paste it here. And let's see the output of our program here. And what I've done here so far is again decreasing the output. So let me get rid of that output here. It's not confusing you. So you remember we have still the static value which the binary was using, and we can do here with all the possible things that we have found with that permutation which matches this checksum. We do an XOR operation, so the exact same thing that we covered here by our reversing session from that binary, and we simply print the output here. And one of those, I don't know, 20 or so flags is maybe the correct one, and that should not super hard to simply try it out. So one of those flags is the right one. Maybe it's your turn to figure out which one, but I hope you have understood how the challenge was working. I hope you had fun, you've maybe learned something, and thanks for watching, and I will say we see us in the next write-up.